To make a review video of some of the things we were dealing with volume. So I'm going to do like 2 problems on this first section, 15.2. And then the second section is a little bit more complicated. That's where I want to do the bulk of our work. So it is important to remember that volume equals the length times the width times the height. We also can say that volume equals capital B, which means the area of the base. This will come up later, so if you're watching this to get the secret messages, you want to know that area, A, equals the area of the base. Sorry, I repeat that because I think I messed that up. You want to know that the big B, the capital letter B, means the area of the base. So I'm going to look at problem 9. A block of wood measures 4.5 inches by 3.5 inches by 7 inches. So I'm going to say that I have a block of wood that's about 4.5 inches long. And then it goes back like that. It's about 3.5 inches wide and 7 inches tall. So I got to draw that. Okay, and then I'm going to draw these lines back here. So when I do the formula, length times width times height, yes, I am taking the 3 numbers, 4.5 times 3.5 times 7, and I get, oh yeah, now we're cooking with gas. I get that, okay? And Mrs. VB has been very adamant that in this case is inches cubed. But what you're also doing when you do this, if I say that that's the length and that's the width, when I multiply the length by the width, I am actually getting the area of the bottom of the rectangular prism. That's the capital B. And I am multiplying it then by the height. Okay? So let's look at another problem. A restaurant buys a freezer in the shape of a rectangular prism. And they tell me that this are the dimensions of the freezer. Okay? So they're telling me that the freezer is 72.5, which is like 72.5, by 24.5 by 36 tall. So while the formula is volume equals length times width times height, I'm taking the length and the width, which also, as I said earlier, make up the area of the base, which is the big B. Okay? So if I come over here, 72.5 times 24.5 is 1,776.25. Now I'm going to multiply that by 36, and I get, oops, oh. Hold on a second, let me grab it. There we go. Okay, so area of the base, 1,776 times 36, which is the height, is 63,945, and this is inches to the 3rd power. So that gives you an idea of how to do these problems. Let's look at the next lesson, okay? So in our secret message, I want you, there's a few things you need to be able to do. You have to be able to tell me that to find the volume, you're going to multiply the length times the width times the height. you need to explain to me that's the same as volume equals capital B times H, because capital B is the area of the base which is length times width. Okay? So if you struggle with what you're telling me, you're writing all of this down and you're coming in, and that way you can walk me through it and say, okay, Mrs. Falk, to find the volume of a rectangular prism, I'm going to multiply the length times the width times the height. That is the same as the V equals capital B times H, because the capital B is the area of the base. That's going to help a little bit when you move into 7th grade. So that's what I want you to know. Okay? Now let's do these problems. And I have both formulas. Jala or Hala has an aquarium in the shape of a rectangular prism with the dimensions shown. What is the height? So in this case, we're not finding the volume, we're finding the height. Okay, so I have to use this formula. Okay? So I'm going to substitute in. We actually say to you, use plug it in, plug it in. So the volume is 3,758.75 equals, okay, the length, which is 24.25. I'm going to put these in parentheses because this means to multiply. Oh, I'm going to run out of room here. Let's figure this out here. I'm going to use this number next, 12.5. And then I'm going to use, what am I finding? And there's a question mark. And I'm going to put H for height. So I'm going to rewrite this now so that it's all on one line. I'm saying 3,758.75. It's going to equal 24.25 times 12.5 times H. So order of operations tells me I can, let's change this color. I can multiply these. I can come over here to my calculator and I can say 24.25 times 12.5 is that number. So I now can say let's get to blue. 3,758.75 is equal to, I multiplied these together, I got 303.125 H. So now what do? This is where I have to bring in what I learned the other day. This is not part of our secret code, but I still need to understand inverse operations. This is multiplication, right? I'm going to do my work over here because I'm running out of room. Okay, so I am going to divide both sides by 303.125. The reason I do that is to cancel it out, meaning 303.125 divided by 303.125 is 1. If you're not sure, you can even check it. Look, 303.125 divided by 303.125 is 1. So I have 1 H there on my paper. On the left-hand side, on the other side of the equation, 3,758.75. Oh, yep, that's right. Divided by 303.125 equals 12.4. The height is 12.4. I can plug it in, and see if that works. I can take the length, 24.25. Oops, I did something wrong there. Right? Times the width, 12.5, times the height I found is 12.4, and I get 3,758.75. It matches. There was a lot of work there, okay? So let's erase my annotations and do another one. Okay. The area of the base of a rectangular juice box. In this case, that's why we're talking about this. They are giving you the area of the base. You can use this one, okay? The volume of the box is 18 inches. The area of the base is 4.5. That means that's a very bad drawing. Whatever the dimensions are, when I multiplied them and I found the area of the base, I got that it was 4.5. I'm going to multiply that by a height that I do not know, and I'm going to get 18. Again, I need to use inverse operations. The inverse, the opposite of multiplication, is division. I'm going to divide both sides by 4.5. If I look at the right-hand side of the equation, 4.5 divided by 4.5 is 1. If you don't believe me, use a calculator. It's 1. And on the left-hand side, 18 divided by 4.5 is 4. Oops, whoa, that messed up. The juice box is 4 inches tall. There's no power there. It's a one dimension. If I measure the height of the box, it is 4 inches. Okay? Let's go on to the next one. A box of cereal is shaped like a rectangular prism. The box is 20 centimeters long. Draw a little box here. It's 20 centimeters long. Oh, that's a very ugly box. Okay? And it's 30 centimeters high. And the total volume, 1,600. Okay? So I need to find this number here. That means 20 is my length times the number in red that I don't know, which is the width. Should put some parentheses here. Times the height, which is 30. I can multiply numbers in any order. So I can say on the left, I'm going to keep this as 3,600. 20 times 30 is 600. Hopefully you are starting to say, this is not part of your secret code, but hopefully you're starting to say, oh, I need to use inverse operations. And then I need to be able to say the opposite of multiplication is division. So I want to undo my multiplication with division. Okay. Oh, I didn't want to do that. It's late in the day. Okay. 3,600 divided by 600 is 6. 600 to 600 is 1. Let's plug it in and see if it works. 20 times 6 times 30 is 3,600. So the width is 6, not cubic centimeters, but just centimeters. Okay? Got that one. Let's clear it and do the next. About 7.5 gallons of water fill up 1 cubic foot of space. How many gallons of water will fill a goldfish pool shaped like the prism shown? Well, I didn't copy the prism shown. So let's go back up here. Let's see. The prism shown is right here. It's 3 feet by 3.5 feet by 1.5 feet. Ooh, let's try to do, ooh, look, we can snip it. Let's snip it. Let's do that. Aha. Let's go here. Let's go here. Which one are we on? Oh, we're on this one. Watch this. Aha. My picture. Great. Okay. So let's go back to my problem here. 7.5 gallons of water fill 1 cubic foot of space. So this is actually confusing. I first need to figure out the volume. Okay, in cubic feet. So I'm going to do volume like I've done before. Volume equals the length is 3. The width is 3.5. The height is 1.5. Okay? So let's do this. 3 times 3.5 times 1.5 is 15.75. The volume is 15.75 cubic feet, which you could write this way. So I found the volume. Now I want to know how many gallons of water is that. Well, if 7.5 gallons of water go with 1 cubic foot, how many gallons of water go with 15.75 cubic feet? So again, we're using ratios to think about that. So to get from 1 to 15.75, I'm going to multiply by 15.75. And I'm going to say, okay, 7.5 times 15.75 is going to equal, okay? So in this case, we have found gallons. It is going to take a little over 118 gallons to fill our pool. I'm going to keep going. We've got 3 problems left. Physical science. A small bar of gold. I'm going to use yellow for this one. A small bar of gold measures 40 millimeters by 25 millimeters by 2. Okay. 1 cubic millimeter of gold weighs about that amount, 0.0005 ounces. Find the volume in cubic millimeters. So that's one thing we need to do. We need to find the volume and the weight in ounces. So first, we're going to find the volume. This is pretty straightforward. Volume, ooh, let's do a color that'll show it better. Volume is going to equal the length, which is 40, times the width, which is 25, by the height, which is 2. Okay, I can do that. 40 times 25 times 2. Okay? Volume equals 2,000. But I need to find the weight. This is where our ratios come back in. So if 1 cubic millimeter. So actually I would write it millimeters cubed. So let's write this as 1 millimeter cubed, okay, weighs 0.0005 ounces. But now I have 2,000 millimeters cubed, and I want to know how much does it weigh. Well, to get from 1 to 2,000, I multiply by 2,000. So this number times 2,000. 0.0005 times 1. All that work to find out 1 ounce. Okay, so that's actually a very small bar. 40 millimeters is like 4 centimeters by 2.5 centimeters by 1/2 centimeter, by 2 centimeters. That's very small. And it weighs 1 ounce. Okay, moving on. A typical stone on the lowest level of the Great Pyramid of Egypt. Okay, so remember we have like the pyramid and here are the stones. Okay. So we're going to just talk about one stone. Was a rectangular prism, 5 feet. Oh, so let's move this over here. So it actually would look like that, right? It'd be 5 feet long. Oh, now they're going to tell me by 5 feet high, by 6 feet deep. And it weighed 15 tons. What was the volume of the average stone? So that's one question. What is the volume of the average stone? And how much did 1 cubic foot of this stone weigh? Okay. So let's figure this out here. Okay. I'm confused already about the weight. I'll get to that. So notice, by the way, that it's length times width times height. If I had put it in the other way, though, okay, the associative property of multiplication, well, we're bringing up those properties again, tells me it doesn't matter what order I multiply numbers in. 5 times 6 times 5 is 150. 5 times 5 times 6 is 150. So it's important to understand that. So I do know right now that my volume is 150 cubic feet, or 150 feet cubed. Okay. And that weighed 15 tons. So if I want to know 150 feet over 15 tons, I want to know 1 over how many tons. So to get from 150 to 1, I'm dividing by 150, right? 150 divided by 150 equals 1. So if I do the same thing on the bottom, I know I'm going to get a decimal. It's going to look weird, but it's okay. 15 tons divided by 150 is 0.1 tons. I could ask you to convert the tons to pounds, but I'm not. It's 0.1 tons. Ooh, let's do it. Let's convert 1 ton, I'm going to tell you, is 2,000 pounds. 0.1 ton is what? So if you say, well, wait a second, I don't know, 1 divided by 0.1, that means I'm actually dividing by 10. So I'm adding more to the problem here. So by the way, it's 200 pounds. Okay, but in tons is fine. So 0.1 ton or 200 pounds if you took it further and did the conversion. Okay, and the volume, if we go back to the volume, was 150 cubic feet. Last problem. Hank has cards that are 8 inches by 4 inches. A stack of the cards fits inside the box and uses up to 32 cubic inches of volume. How tall is the stack of cards and what percent of the box's volume is taken up by the cards? There is a lot going on here. So first of all, I think that's a mistake. Let's see. He has a box that's 8 inches by 4 inches. I'm going to look at this one for a minute. So that means 8 times 4 is 32. And if you don't remember, I told you in your secret code that you needed to know that volume equals capital B times H, means the area of the base. Okay? A stack of these cards fits inside the box and uses up to 32 cubic inches of volume. How tall is the stack of cards? Eight by 4, but they want 32 cubic inches. So the only way, if this is already 32, this is 30, well, let me write this. This is tricky. I don't know what this is what I'm looking for, but this is 32 inches squared because it's the capital B. It's the area. So I need volume. I need 32 times some number is going to give me 32. So that means that number is 1. Okay? Okay? So in this case, what they're saying is, since it only takes up 32 cubic inches, it's only one, his stack is only 1 inch high. I think I see it now, but they're saying that there's 4 inches in that box. So if 1 inch is what he takes of the total, 1 divided by 4 is 25.05 or 25%, if you're not sure. So he's taking up 25%. So it's 1 inch high, and I'll put over here, he's taking up 25% of the total. Wow, that one got tricky. But if you've watched the video, you know what you're doing here. Oh, I already erased. Oh, no. And the secret code, again, is there. It talks about capital B is the area of the base. And to get the area of the base, you're going to multiply the length times the width. That is why volume equals length times width times height is the same as volume equals capital B area base times height. Thank you for watching.